So make sure you do that. It's on the test. I am asking for integrity of the exam until your exam graded is returned to you, meaning no discussions about the questions, no looking up the questions, no posting on Chegg, no looking on Chegg, etc., etc., etc. Wait, take the time off after you take the test, right? If somebody's sharing something with you about the test, ignore it. Don't look at it. Take the test yourself. Show me what you get on your own, okay? Once I give you the exam back graded, do whatever you want with it. And so this one I'll be able to grade quickly because it's all, everyone will have the same question, and I'll be able to answer everything, post the solution Friday, and then grade and give it back to you on Monday. All right, the first question here is from Cindy, and we're talking about polynomials with zeros and their multiplicities. So that first question that I give, that you have there, I mean, I don't think you're asking anything there. I think you got it, right? Maybe it's the second question, Cindy? So I have 3 zeros. I have a 0 of 3 with a multiplicity of 1.
Yes, it's the second question.
The second question, yes.
Yep.
So they give me, so find f of x, right, with the following zeros. And it tells me n is 3. So I know it's degree 3. So I know it has at most 3 zeros, right? And it tells me the zeros and the multiplicities. And I will ask for this on the test. So it gives me that I have a 0 of 3 with a multiplicity of 1 and a 0 of negative 1 with a multiplicity of 2. The sum of the multiplicities should equal n every time. That's not true. Sorry. Well, it is true if I consider complex zeros. But for our test, it will be equal. The sum of the multiplicities will be equal to 3 if it's a polynomial of degree 3. I'm not giving any complex zeros on our test. Cindy, go ahead.
No, just you made it clear
that
the sum of the multiplicities is equal. Okay.
Yeah, for us, I'm gonna make sure that you don't have complex zeros. So we might see one today with complex zeros, and then the sum of our multiplicities will be at most n, right? At most n. So, but if I have all real zeros, it will be equal to n. So on this one, I've got a times x minus 3 times x plus 1 times x plus 1, because that 0 of negative 1 is repeated twice. That's what the multiplicity means. And so, of course, I could write this as x minus 3 times x plus 1 quantity squared. And because they don't tell me anything about a point, I can pick the simplest version of a, which is going to be 1 every time. Okay? And there's nothing like this on your test. So I'm gonna let a equal 1. And so there's my final answer. F of x equals x minus 3 times x plus 1 quantity squared. Now, what do we know about it? We know it's a polynomial with a mother function x cubed, right? So x cubed, so there it is. At most n minus 1 turns, and at most 3 zeros, right? At most 2 turns and at most 3 zeros. And we know a little bit more. At negative 1, it bounces, and at 3, it goes through. So we know it starts up and bounces, and then at 3, it goes through. And of course, what are you going to do? You're going to instantly put this in your calculator and see the same thing, right? The whole test, we're kind of cheating use the calculator to find the answer. Show me the algebra so that you understand how the calculator is getting you everything. And you're going to do that all through Calc 1, Calc 2, and etc. You're going to find the graph, look at the graph, and then show the algebra and or the calculus to verify things. Cindy, what do you think?
I didn't put it in the graph, so I think putting it in the graph makes it so much more easier.
Exactly.
I didn't do it.
Yes, and that for me, that's what really works for me. Like if we're driving the car and my girlfriend says turn left on McLaren Street, I'm like, what the hell? Tell me turn left after the red house. You know, I need a visual. Well, one, I'm a man, but it's a lot. We're trying to work both sides of the brain, right? Use the graph and use the algebra, and then things should click a little bit easier.
Yeah, thank you.
Yeah. McLaren Street, where the hell is that? That's the street I grew up on. All right, Isaiah got me a question at least. Oh, viewing window should always work on standard, Zoom standard. So I'll do this one on Zoom standard, okay? So Isaiah sent me a very similar question. He says I have n is 4, and I have zeros, all of multiplicity 1. My zeros are -5, -2, 4, and 5. So, and again, I don't care about a. In this case, I can let a be 1. So f of x is x plus 5, x plus 2, x minus 4, x minus 5. And, you know, I'm going to give you everything in standard form. This is in factored form. I'm going to give you everything in standard form, right? And then you have to turn it into factored form. So I don't really feel like distributing all of this out. So I'd rather just put it into this form. I don't even need to. What's the mother?
X to the 4th.
Yeah, x to the 4th. So I already know worst case scenario, right? 4 zeros. Oops, sorry, that's 5. I already know worst case scenario, 4 zeros, 3 turns, right? In fact, that's what I have here. I have exactly that worst case scenario, right? I'm going through -5, -2, 4, and 5. So it should give me a decent window with Zoom standard. Zoom 6 should give me a decent window. And if not, I can do Zoom fit. So this is Zoom standard on the calculator. Zoom 0 is Zoom fit. But I think the ones I'm giving you, Zoom standard will be fine. Isaiah.
Yeah, I'm following you.
Yeah, do you want me to graph that one on the calculator? I will.
I actually put this here. I know it's funny because you said you didn't feel like factoring it, but that's kind of why I put it.
No, I don't. It is factored. I don't feel like distributing it, but I will if you want me to. So
Yeah.
I get an x squared plus 7x plus 10 times an x squared minus 9x plus 20. And then I get x to the 4th minus 9x cubed. Sorry, you have to watch me do this, but 20x squared, 7x cubed, 9 times 7, 63? Yeah, minus 63x squared, plus 140x, and then finally 10x squared minus 90x plus 200. So I get f of x equals x to the 4th minus 2x cubed minus 33x squared plus 50x plus 200. So there's my standard form. Again, I'm gonna always give you standard form, and you're gonna give me factored form.
Well, I think I did it wrong because I just put the x plus, I put them in the wrong order.
Yeah, it shouldn't matter because you're adding things, so it shouldn't matter what order you put them in. But this is the norm is to write them in descending order of power.
Oh well, then I can't add then.
Yeah, that could be it, and that happens.
Yeah.
It happens. The more math you learn, the worse you'll be at simple addition. So, at least that's the excuse I keep telling myself.
Thank you.
You got it. Wilder. What the hell? I can't. Where did you get this problem from? I didn't assign that. But I'll do it the way I want you to do it, okay?
It was on the review.
Oh my god. That's my fault then. You know, always when you get something that looks really strange, curse out the teacher first. That's what I always did. And then get over it. So f of x, remember, do everything the way I'm doing it. That's what I want you to do. So I have a function 8x to the fourth minus 2x squared plus 7x minus 1, right? And so what am I going to ask you to do? I'm going to ask you to factor this and find the zeros. So let's go to the graph, because that's how I want you to start. Now, of course, there are possible rational zeros, right? Possible rat roots of plus or minus 1 over 1, 2, 8, right? So I've got plus or minus 1. Plus
You forgot 4.
Oh, thank you. Plus or minus 1/2, plus or minus 1/4, plus or minus 1/8. And so I'm going to look at the graph and figure out which one I want to start with, right? So that's where I'm going here. I'm going to go to Desmos. Unless somebody wants me to do it on my TI-83.
Wait, can you do it on the TI?
Sure. The only reason why I don't like to use the TI is because it's tiny on the screen, but I don't mind at all. So I'm going into y equal, right? And I had 8x to the fourth, so 8x to the fourth. Oops, sorry. 8x. Come on, I can do it. There we go. One more time. 8x raised to the fourth, right arrow, minus 2x squared, right? Minus 2x squared plus 7x minus 1. And I'm going to graph. I'm going to zoom standard. Everything I put on your test should work zoom standard. And it looks like I'm hitting -2. No. -1, right? No, it doesn't look like I'm hitting -1. So it looks like maybe 1/8. So I'm going to try 1/8 first. I mean, you know, I'm just going on the graph, and the ones I put you on your exam are a little bit clearer. But it looks like 1/8 to me. Maybe it's a quarter. So I'm going to try both of those. So I'm doing 1/8 into 8, 0, -2, 7, and -1. Is everybody okay with that, especially the 0?
I have a question. For the possible roots,
Yes.
are you going to provide that on the test?
No, it's just the factors of the constant divided by the factors of the leading coefficient.
Oh, okay.
And I will ask for that, so make sure you have that on your formula sheet.
Okay. Thank you.
Yep. So let's see what happens. I don't know if this is going to work, but we'll find out. It doesn't look like it's working already, but so Wilder, am I right? The question said there's a root between 0 and 1, right? And we clearly see that there's a root between 0 and 1. So if it's a rational root, it can only be 1/8 or 1/4, right? It's definitely not 1/2. Wilder, you with me?
Yeah.
Yeah. So I'm trying 1/8 first. So 1/8 times 8 is 1. Multiply, I get 1/8. 1/8 minus 2. Not loving this question right away here, but
It gets -3x.
-7/8.
Yeah, other way.
Yeah. So -2 plus 1 divided by 8. -15/8. It's not looking good for me here, right? No. No, so not a 0. So I'm hoping, right? So forget it, didn't work. I'm hoping 1/4 works. I'm not too hopeful because I don't know what the hell this question is asking, but let's try it again. So bring down to 8, multiply, I get 2, add, I get 2. 1/4 of 2 is 1/2. Add, I get -3/2, right? -3/8. Oh my God. No, it's not a 0 either. All right, so I can see why you asked about this one. But the one I am going to give you has nothing to do with what the hell they're saying here in this one, Wilder. It will always be one of the rational roots if I ask you about rational roots. And this one is not. This one's got 4 irrational roots. Okay? So not going to happen for us on our test. Is that okay if I leave it there?
Yeah, it's just the example, when I looked at the example, it had something to do with like the midpoint formula, which was kind of confusing to me.
Yes, but I never taught you that, so I'm not going to test you on it.
Right, so yeah, okay.
Yep.
Okay.
So let me actually show you the one that I did with rational roots in the other class today, okay? Because that will alleviate some of the panic, I think. Here it is. So this was the function, and I certainly could see myself asking you one like this. I did not. where it's not real clear when you look at the graph where the root is, okay? But, so here's the function 7x cubed minus x squared plus 7x minus 1. And I graph it, and here's 1 and here is minus 1. And I'm looking at my rational roots. So really, my only choice is 1 over 7, right? It's definitely not plus 1 or minus 1. And it's not a negative root. It's a positive root. So the only one that's left is that positive 1 over 7. And that one turned out to be the root. But you'll see the ones that I do, they'll be a little bit clearer on the test. Trying to make the test nice and pretty and simple, so that, you know, there's no real crazy question on there, that everyone should be able to get everything right. So that's on the recording, Wilder. So look at that one on the other recording, okay? I think it's like the fourth problem I do.
Okay, thank you.
Yeah. And like I said, when you get something really weird, just curse out the teacher and then ask. And then everything will be fine. All right, Jamal, to see. Yeah, there's one like this on your test. So I've got a quadratic of x squared plus 2x, right? Does it open up or down? Well, you're going to graph it in your calculator, and clearly it opens up, right? I have a 0 at 0 and a 0 at minus 2. So it's doing something like this, right? But of course, we want to complete the square, right? I'm going to ask you to complete the square. So I've already factored out the leading coefficient, right? And so what's k? It's 2, right? K is 2. Half of k is 1. Square that, I get a 1. I'm going to add it and subtract it. Add it on the inside, subtract it on the outside. And now my vertex form is x plus 1 quantity squared minus 1. And so you could see I get a vertex at minus 1, minus 1. So I'm asking you something just like that on the test. A little bit more complicated, but you have to be able to complete the square. Jamal, is that okay there?
Yeah.
Now you got another one on here, right? Good, this is a good one to do, okay? So if you watch, and I'm a little worried that you're all not asking more complicated questions. I mean, the one Wilder asked is way too complicated, but that's okay. I don't even know how that got in there, but go ahead.
Professor?
Yeah, Jamal.
The question also asks for what is the equation of the axis of symmetry?
Oh yeah, the axis of symmetry. If you look at that, and I don't ask for that on the test.
Oh, okay.
But the axis of symmetry, right, is always x equals x sub v. So in this case, it's the x coordinate of the vertex is -1. So it's symmetrical about the line x equals -1.
Okay.
You would have learned it in like middle school as x equals minus b over 2a. Same thing. The axis of symmetry is x equals minus b over 2a.
Got it.
Yeah. Right, that one should sound familiar to everybody. And of course you hear that in x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And you can see that minus b over 2a in that quadratic formula.
Did they make you sing that song?
What? Pop Goes the Weasel, what? Did they make me sing it? No one's making me do anything. The only thing I have to do as a human is die, right? And I'm a procrastinator. I'm waiting to the very end of my life to do it. It's funny, right? Thank you, Elise. Ryan, are you in an Uber or something?
Yeah.
Okay. All right, so Jamal sent this one. This is a good one to do. And let me do more than what they're asking, okay? Because let me do what I'm going to ask. I'm going to ask you to give me everything you can about this particular function, including the graph. But of course, you're going to do the graph anyway. Anytime I give you a function, you're going to do the graph. This is almost standard form, right? If I distributed the 5, what is that, 160? No, 3 times 360, right? Yeah. 6x squared minus 486. So there's my standard form, and when I graph it, I want to put it in standard form. I can get away with not going to standard form if I wrap everything in the numerator, wrap everything in the denominator, and I want to do that even if I am in standard form. Weird things can happen if you don't wrap the numerators and denominators. Like for example, if I typed in y1 equals 5 times x squared minus x minus 72 divided by 6 x squared minus 81, it's going to take this x squared minus 81 and think it's in the numerator. So you have to be really careful about the calculator. It's pretty dumb. Okay, so you have to be really careful about how you're putting things in the calculator. Well, not only do we want standard form, but I'm going to ask for what? I'm going to ask for factored form and possibly reduced form, right? So going back to this first version, I can get my factored form. Who's got the upstairs for me? Who's got the factors of the upstairs for me there? Who's got that? Very good. Right, 9 and 8. 9 times 8 is 72. Minus 9 times positive 8 is negative 72. Minus 9 plus 8 is negative 1. I need the coefficient of that middle term, right? What about downstairs? X minus 9, x plus 9, right? So there's my factored form. Everyone okay there?
I can't do that. I'm really slow at it.
That's fine. You should have time. I'm giving you 5 questions in 85 minutes, and you can, if you're wondering about factoring something, right? Like if you're wondering about factoring this thing, you could graph it, right? And you would see it goes through negative 8 and positive 9, and you can do synthetic division to factor it. Right? So if you're having trouble factoring quadratics, you could treat them just like a polynomial, which they are. Look and see where it hits a 0 and do synthetic division on it. Does that make sense at all?
Yeah.
Nice. So there's my factored form, and then you can see that I've got matching factors there that are going to cancel, and here's my reduced form. The important thing is when I'm talking about my reduced form, I must have the domain from the original. So the domain of f, whether I'm looking at the standard form, the factored form, or the reduced form, is still x cannot equal plus or minus 9. What happens at minus 9 is I get a vertical asymptote. What happens at plus 9, though? Who can tell me what happens at plus 9?
Are you gonna get the intercept?
Nope.
A hole.
A hole, yeah.
There we go.
Yep. And the hole is not easy to see. You could see it in your table. It'll say x is 9, y is undefined, right? But of course we can find the height of the hole by doing f of 9 in the reduced form, right? So I'll call this guy little r. So that's 5 times 9 plus 8 over 6 times 9 plus 9. So 5 times 17 over 6 times 18. So there's a hole at, don't tell me, 85 over 108. So when x is 9 and the height is 85 over 108, there's a hole in the curve there, right? This is something called a removable discontinuity. We're gonna learn how to patch that hole in Calc 1. We're gonna learn how to put it like if you see them digging a hole in the street, they put this big sheet of metal, right? That metal plate over it, so no one will go into that and ruin their tire. And that's something we learned in Calc 1, how to remove a discontinuity. What else should we have to be able to do here? I should be able to find x and y intercepts. An x-intercept when the numerator is 0, a y-intercept is when x is 0. So I have an x-intercept at -8, 0. I have a y-intercept at 0, 40 54ths, or 0, 20 27ths. So when I set my numerator equal to 0, I get x-intercepts. When I set x equal to 0, I get y-intercepts. And of course, I'll be able to see both of these on the curve when I graph it. So I've got a vertical asymptote. What about a horizontal asymptote?
It's gonna be 1.
Almost. Very close to 1. F
Is it y equals 0?
So what's my leading term? 5x squared over 6x squared. So that's 5 over 6. So y equals 5 over 6 is the horizontal asymptote.
Wait, that's so much easier than the way that they try and teach us on Math Excel.
I told you. My job is to interpret the book as easy as I can, as easy as it should be. And Math Excel is just a bunch of super nerds. Maybe either they're computer scientists or they're mathematicians, but they're not both. And so when you try and write a program to teach this, it's not easy. It's not easy to write it. And so it ends up being very convoluted. So what else do I need? Short run behavior. Where am I going to be able to do short run behavior on this graph? There's two possibilities and one is wrong. Where is the short run behavior going to happen? Where am I interested? Go ahead.
Isn't your short run behavior your vertical asymptote?
Exactly.
No.
I want the short run behavior at a vertical asymptote. So at positive 9, there's a hole. And I already know the short run behavior there. It's around a height of, what did I say, 85 over 108. Okay. So, but at negative 9, right, that's where the vertical asymptote is. I want to look at what happens when I plug into the reduced form at negative 9. So I get 5 times negative 9 plus 8 over 6 times x plus 9. I can't plug it in to the x plus 9 because I'll get a 0 downstairs. So I get a short run behavior of negative 5/6 times 1 over x plus 9. So I'm seeing the behavior of negative 1 over x. I should see the behavior of negative 1 over x. Right? So negative 1 over x looks like this. So at that vertical asymptote, at that horizontal asymptote, vertical asymptote, at that shift of the origin, I should see the behavior of negative 1 over x. Is everybody with me there?
Yeah. And is it always the short run barrier, either 1 over x or negative 1 over x?
It could even be a 1 over x squared or negative 1 over x squared, but it's never anything different than those two.
Okay.
Even if it turns out to be negative 1 over x cubed, that still looks like 1 over x. If it turns out to be 1 over x to the fourth, that still looks like 1 over x squared. So it's going to either look like 1 over x or 1 over x squared. For the ones I'm giving you, I'm not going past the third power of short run behavior. And remember, you're going to be able to see the graph already, and all you're doing is showing me the algebra that says, hey, look, I understand this. Right? Even if you don't. And I'm talking to everybody. So let's see what happens now if I start the graph, right? So negative 9, right? Positive 9. Yes? Vertical asymptote at negative 9, correct? I got a hole at 9. I don't know where it is. I know it's, what number was it? It's like a little bit bigger than 1. Is that right? So there's a hole in the graph at 9 comma, whatever it was. What was it? 106? Oh, I forget. Less than 1. 85 over 108. So less than 1. Sorry about that. I have, what is 85 over 108? And what is 5 over 6? Nice. So it's underneath my vertical asymptote of 5 over 6. So 5 over 6, I've got a vertical asymptote. What else did I have? I had an x-intercept and a y-intercept, right? Help me. What's my x-intercept? 8, 0, and then the other one is 0 less than 1. So that's going to tell me something about what's going on in the graph, right? At negative 9, I had a behavior of minus 1 over x, so I know it's got to be up here, and you can see my new origin is vertical asymptote, horizontal asymptote, right? And then the other one is here. And there it is. There's my graph. And again, you're going to look at the calculator and see exactly the same thing. You won't see the hole, right? But you'll see just about everything else.
So the hole is what's in the real one, but not in the circle.
Exactly. And you're going to see this is going to be a trick. This is going to be a trick in Calc 1. Is if I can replace the function with a hole in it, with a function without a hole in it, right? So they're identical everywhere except for where that hole is. Then I can do so much more with it with the tools of calculus. If I have that hole in the graph, I can't take derivatives. How can I draw a slope there? How can I stand on that point on my skis if there's a hole in the mountain there, right? I'll fall through. So one of the things we do in Calc 1 is we try and get these replacement functions. This function that's going to work better with the tools of calculus, right, than this function that actually is what we have. So we can kind of pretend at that one trouble point that it isn't trouble. And this is again called that removable discontinuity. It's like, well, if I could escape the Earth's atmosphere at this angle, what speed would I have to be going? you're kind of thinking of these theoretical things that can't really happen, but if they could happen, what would they be? And this is a God. This is the God equation kind of thought. What could possibly be, even though it might not be, right? And so this is a big part of calculus and how it describes what's going on in the universe. It's kind of cool, actually. Well, is that it? Is that it? No more problems to do? It's fine with me. I want to go eat lunch, but if you got more to do, I'm happy. Oh, I'm sorry, Elise. Elise sent me one in the chat. Thank you. So Elise sent me one, and let me just take another quick photo of attendance. 3, 6, 9, 12, 15, 18, missing 3 students. What the hell?
Wait, is anybody else going?
If you got another one for me, I'll take it. But I'm going to do one from Elise, and then I have nothing else on my list after that.
Okay, I'm gonna take a picture of it and send it to you really quick.
I like it. So this Elise put this one in the chat. I think it's about a vertical asymptote. Am I right? But this is a good one to do. Oblique asymptote, right? Elise, no?
Yeah, sorry, I was on mute.
No problem. Yeah, so I like this one. I like something like this on your test, actually. I didn't put an oblique on your test, but I do like this function. So we can look at it anyway. So this is my standard form of the function, right? So what am I going to ask you to do? Everything. Graph this. Find intercepts. Find vertical asymptotes. Find holes. Find horizontal asymptotes or oblique asymptotes. Find a short run behavior. Give me the graph completely labeled, right? And so you'll see you're going to have that one question. It's going to have 6, 7 parts to it. It'll take you a couple of pages, but just take your time. Use the calculator, right? So we want to first put this. Oh, I'll say, give me standard form, give me factored form, give me reduced form if it exists, right? So this first one, well, downstairs is easy, right? This is what, x minus 2, x plus 1? Is that okay?
Yeah, I think I got that wrong. Oh, no, I'm looking at the wrong problem. That's it.
Yeah, I'm looking at the second one you sent me, right? The first one we kind of talked about already.
Yeah, I realized that the issue that I had was I was doing problems on the whiteboard, so I started like writing them down. So I did half of this problem, and then I got frustrated.
Okay, I get it. So the top one, if I don't know how to factor this, I'm going to put it in the calculator, and I'm going to see it goes through 2. Right? On this top one, I'll see it goes through 2. So I know it's got a factor of 2, and then I'm going to use synthetic division to get that depressed equation. So I'm checking 2 into 1x cubed, 0x squared, 0x minus 8. Don't let me go too fast. Is everybody with me? I'm factoring that x cubed minus 8. I know 2 is a 0, right? And so I'm going to use synthetic to find the other factor. So multiply, add, multiply, add, multiply, add. So my other factor is x squared plus 2x plus 4. Is everybody okay there? At this point, I can find my domain. X does not equal -1 or +2. And again, I can find my reduced form of what? X squared plus 2x plus 4 over x plus 1.
Professor,
Yes.
could we factor that at the top, or should we just leave it?
Anything yes, you can. If you can factor that, if you just know how to factor that, it's fine with me. It is
Okay.
algebra 2 stuff, yeah. But if you don't, then that's why I did the synthetic trick, right? If you don't...
Oh, my bad. I was going to say, Professor, I just sent the question.
No problem. No problem. I'll get to it next, okay? Oh, I got it. Okay, so I've got my standard form, right? I've got my factored form. I've got my reduced form. And I still know my domain is the same. No matter what form I'm looking at, my domain is the same. I cannot plug in 2. I cannot plug in -1. If I plug in -1, I get a vertical asymptote, right? So I have a VA of x equals -1. I have a hole at x equals 2. Yes, you with me? And what do I get when I plug in 2? I get 2 squared plus 2 times 2 plus 4 over 2 plus 1. Right? I'm plugging that into the reduced version because that's where I can plug it in. So what do I get? I get 2 comma 12 over 3, 4. 2 comma 4 is a whole. At least so far? Yeah, nice. I have...
Professor?
Yes.
How come
Sure.
the whole would be at 2 instead of 1?
Well, so first of all, my domain is -1, right? So if I plugged in -1, I get a vertical asymptote because
Right.
they didn't cancel. So that hole happens where those factors cancel.
Oh, okay.
Right. And again, in Calc 1, we call it a removable discontinuity. So I need a horizontal asymptote, but it doesn't exist, right? Because what do I have? I have y equals x cubed over x squared, which is x. So that's an oblique. Y equals x. Y equals x is on a slant. Oblique asymptote is also called a slant asymptote. So I'm on some angle, some y equals mx plus b. That's not a zero slope, right? So I want to find that oblique asymptote. Would you like me, Elise, your choice, long division, synthetic division, or both?
Can you do both, please?
Yes. So I'll start with long division using the original function. I've got an x squared minus x minus 2 into x cubed plus 0x squared plus 0x minus 8. Again, I need placeholders. I need a placeholder for every power when I'm doing long division or synthetic division. I'm now asking myself, and don't let me go too fast here. I feel like because I'm hungry, I want to go eat lunch, I might be going too fast. So, and I'm not too excited about lunch. It's cauliflower crust pizza. It's like when you get old, you got to start eating crap that you would never think about. But I'm diabetic, so now I'm asking what times x squared would give me x cubed, right? What times x squared would give me x cubed? And of course that's x. And then I come back and multiply, right? I come back and multiply to everything to do my long division. So I get x cubed minus x squared minus 2x. And then change my signs and add. Change my signs and add. The first term goes away every time that we get rid of that process with synthetic. We also get rid of change the signs, right? So I've got x squared plus 2x minus 8, and I rinse and repeat. So now I'm going back to the beginning of my long division, going back to that process, and I'm saying x squared times what will get me x squared, right? Watch it again. X squared times what will get me x squared, and that's 1. And then I come back and multiply to everything. So what do I get? I get x squared, I get 1 times x squared is x squared, 1 times negative x is negative x, 1 times negative 2 is negative 2. Change my signs and add. So I get 3x minus 6. And I'm done. X squared doesn't go into 3x anymore. So this is a remainder. And remainders are like pennies to me. In the long run, if I have millions of dollars, I don't care about the remainder. Keep the change. I'm so rich, keep the change, even if I buy a car, right? So there's my oblique. So the oblique asymptote is y equals x plus 1. I did not put an oblique asymptote on your test. I think doing it in the homework is enough. If you can get it in the homework, then I don't care about testing you on it. I think we have everything we need except for short run behavior, but we'll cheat that on this one because we already did it once today. Let's see what happens here for our graph, right? Don't tell me. So at y equals x plus 1 is my oblique asymptote, right? At x equals minus 1 is a vertical asymptote. Did I have intercepts? Oh yeah, 2, 0, right? And 0, 4. I'm just doing those in my head real quick. I found out where the numerator is 0. Oh, and when x is 2, yes, and 2 comma 4 is a whole, right? Cool. I really don't want this point here. Now, if I did some short run behavior, I think it would tell me something. I feel like I'm missing something. No. I'm making a mistake here. Sorry, my x-intercept is wrong. There is no x-intercept. Because when I plug in 2, I get the whole, right? So I believe my graph is right here, but and you can see it's pressed between my vertical and my slant. Let's look at short run at -1. What do I get for short run at -1? I get f of -1 is -1 squared plus 2 times -1 plus 4 over x plus 1. I get 5. I get 3 over x minus 1. So yeah, it's looking like positive 1 over x. So you can see the 1 over x. Here's the up, here's the down. Right? 1 over x looks like up and down. And then the slant, right? I can't cross that slant in the long run. That's a tough problem. The one on your test is a little easier. It will have a hole in it, but it will have a horizontal asymptote instead of a slant asymptote. But again, you're going to be graphing it on your calculator first thing, and you're going to know what it looks like. And so if I'm graphing this on my calculator in y1, I'm putting f of x. And once I get y2, once I get my slant asymptote, I'm putting that in as well, and then it will really show me. It'll really show me that the curve is getting really close to it. Isaiah, you sent me something else? Yes? Yes, good.
Yeah.
Good. Elise, that's okay though? Is that,
Yeah.
do you want me to look at the other one too, or is that one you got?
I think that's good.
Okay. Yeah, nice. So this one, and so I'm not going to give you a graph. I'm just going to give you a function. But let's look at that function that Isaiah sent me here. So Isaiah sent me the function f of x equals x squared over x squared minus 9. Perfect, right? So we should be able to do the same thing. This is what? X squared over x plus 3, x minus 3. And you can see I have vertical asymptotes of x equals plus or minus 3. What about the horizontal asymptote? Y equals what?
Would it be
1.
0?
Y equals 1. So I'm looking at x squared over x squared, right? I'm looking at the mother of the numerator over the mother of the denominator, and they're the same. They cancel. So I just get the ratio of the coefficients, of the leading coefficients.
It's 0 if it's like, say if the bottom was 3, then it'd
Exactly.
be 0, right?
Exactly. So if I had an x squared over x cubed, that reduces to 1 over x, and 1 over x, of course, has a horizontal asymptote of 0. Right?
Got it.
Yep. Yep. So, we have an xy intercept of 0, 0, right? I mean, we could start there, right? So at 0, 0, I have a point. At positive 3, negative 3, I've got asymptotes. At 1, I've got a horizontal asymptote, right? And remember, I'll never cross a vertical. I can cross a horizontal. I can already see when I plug in positive 3, I get a behavior of 1 over x. So I get a short run behavior of 1 over x. And when I plug in negative 3, I get a short run behavior of negative 1 over x. Does anybody want to see that? F of 3 is 3 squared over 3 plus 3 times x minus 3. Remember, I can't plug the 3 into x minus 3. I get a 0. But I can plug it in everywhere else. And I get 9 over 6 times 1 over x minus 3. And I'm seeing a positive 1 over x. I'm seeing some kind of positive 1 over x. Yes, stretched out and shifted, but still looks like 1 over x. Right, in the green. You see the green looking like 1 over x? Right, you see the green, I've got this part of the green, and I've got this part of the green, right? So they gave you a graph. I'm not giving you a graph. I'm giving you a function, and I want the graph. And I want a rough sketch of the graph. I want everything labeled. So on this one, I would label y equals 1 is my ha. X equals negative 3. X equals 3 are the VAs. I've got 0.00. And this is the function f of x, right? And then you include the short run behavior, right? And so I'm going to prompt you. If I want short run behavior, I'm going to ask for it. If I want a vertical asymptote, I'm going to ask for it, right? Everything I want, I'm asking for. And then it's up to you to give me as much detail in the process as you can. You can't talk to me on the test, so you got to write it, right? I can't wait to see what you do. I really can't. I know it's going to be better than last time. It better be better than last time, or you're all in trouble. So I have a feeling you're going to give me some good results here. I looked at how many of you did the study guide. It's pretty bad. It's pretty pitiful. What can I do?